Hello everyone, I am Dr. STRESSORS. I welcome you in my YouTube channel. Today in this video, I am going to talk about chemical equilibrium. My friends, this is also very important topic. Really, if you believe, then it will be very important topic for you. Actually, for examination purpose, NET, GATE, LAT examinations, 10+2 examinations. So, for chemist, you should know about the chemical equilibrium. Dynamic process. What is dynamic process? Both forward and reverse reactions continue, but there is no net change in the amount of reactants and the product. So, chemical equilibrium means what? You have one graph, and that graphical presentation is molarity versus time. The concentration of reactant decreases and concentration of product increases with time. And one time will come where equilibrium is established. So the equilibrium point is actually a point in reactions where a specific mixture of reactants and product has obtained a minimum energy state. The most stable state of these to temperature dependent conditions. Now, about the Chatelier principle. When a system at equilibrium experiences a stress, the system responds to relief. The system responds to relief that stress by changing the ratio of the reactants and products. It shifts right or left. Now, stressors. Concentration changes of R or P, temperature changes, pressure and volume changes. So, concentration changes only affect reactants or product in the aqueous or gaseous state. Pure solid or liquids don't have concentration. So we'll consume what is added or replaced and what is removed. So consider the following reaction: A gas plus B gas, it gives C solid and D gas. Adding more A will cause the reaction to shift to the right, the direction that consumes A. Now, consider the following reaction: A gas, B gas, C solid and D gas. Remove some B will cause the reaction to shift to the left, the direction that replaces B. Now, consider the following reactions: A gas plus B gas, it gives C solid and D gas. Adding or removing carbon has no effect on equilibrium position since it is in the solid state. So, consider the following reaction: A gas, B gas, it gives CAs and D gas. Which direction do you think it will shift if some D is removed? Yes, that's right, to the right. Now, temperature change. Effect depends on whether the reaction is endothermic or exothermic. Increasing the temperature is like adding energy. Increasing the temperature is like removing energy. So, temperature changes in endothermic reaction. Energy is written on the reactant side. Energy A plus B gives C plus D. In exothermic reaction, energy is written on the product side. So, A plus B gives C plus D plus energy. Now, consider the following reactions. A plus B gives C plus D plus energy. Is this endothermic or exothermic? Which way will it shift if the temperature is increased? Yes, that's right, to the left. So, consider the following reaction. 25 kilojoule plus A plus B, it gives C plus D. Is this endothermic or exothermic? Which way will it shift if the temperature is decreased? Yes, that's right, to the left. Now, pressure volume changes. Pressure volume changes only affect the reactant or product in the gaseous state. Systems that differ in the number of moles of gaseous reactants and the product responds by the shifting to a more or less compact states. So, pressure volume changes. Consider the following reactions. A plus B gives C plus D. How many moles of gaseous reactant or products are represented on each side of the arrow? So 2 mole on left, 1 mole on right. So example 7, A gas plus B gas is in equilibrium, solid and D gas. Which way will it shift if the volume is decreased? Pressure increase. Yes, that's right. To the right. Factors that do not affect equilibrium positions. Adding a catalyst, adding an inert substance like noble gas. So effect of catalyst. Speeds up the rate of establishing equilibrium but will not affect the equilibrium positions. So effect of inert substance does not change any reactants or product concentration, does not change temperature, does not affect any individual gas pressure, thus no effect on equilibrium positions. So equilibrium expression. An equilibrium expression computes an equilibrium constant, equilibrium, and this constant is the ratio of product to reactants raised to their stoichiometric coefficient once equilibrium has been established. Again, pure solids and liquids are omitted from the expressions. So, for the following reactions, AA gas plus BB gas, it gives CC solid, DD gas. So, K equilibrium is equal to DD, AA and BB. So, equilibrium expression, meaning of K. If K greater than 1, then its product favor. If K is equal to 1, then it's neither. If K less than 1, then its reactant is favorable. So, my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.